Welcome to this video. I want to go through step by step how to make this in FreeCAD. I expect this to not only be a long video, but to also have a lot of rebuild time. So if you get caught in a long rebuild, just let it continue and it will work out. So I'm going to take the rebuild time out of this video, otherwise casual viewers will be driven crazy. So you'll probably have to pause the video as needed, but it will rebuild. Just be patient. FreeCAD does a really good job of making the graphics be reflective. I mean, it's pretty impressive what FreeCAD can do. You'll also see that we have all the bolt holes. We have coolant channels, freeze plug channels, of course the ports for intake and exhaust. You have your coolant and temperature sensor studs. I mean, you have your spark plug tubes, oil supply and return channels, camshaft retainers. I mean, you have just about everything you need for a decently complete model. And I want to go through how to make this again step by step. Let's make a better version of this where some of the shortcomings and maybe some things that are dimensionally unrealistic, let's fix some of that and make something that's pretty robust. Let's get started by making a new part. I'm going to go back to the start page, create new. Let's go around the part design menu. So I'm going to create a body, create a sketch. When I orient this, I think the XZ plane is the most appropriate plane for proper orientation. I'm going to make a rectangle and we'll add the symmetric relation to it, and that way we're always centered around the origin no matter what we do. Shift H for horizontal dimension, and I'm going to make that 5 inches long. Shift V for vertical dimension. We'll make that 3.5. And now as I close this, we can go to the tasks and pad it. And let's pad this 15.25 inches. We'll make that symmetric to plane. So now that we have our oriented starting block, I want to get started by making another primarily reference sketch, but we'll have some driving dimensions. And what I'll do here is sketch on this bottom face and create a bunch of reference geometry. I'm going to make these referenced like cylinders. In fact, I'll just make all 4 so that we have a kind of a complete picture of what's going on here. So again, I use the E key and highlight every one of these to make these equal in diameter. We'll use a polyline and connect every center. I'm going to use the V key for vertical, and again the E key to make sure that these are equidistant. And now I can add some dimensions. Shift V for vertical dimension. We're going to make that 3.5, so the spacing between our cylinders is 3.5. Let me call out a diameter here. Let's make this diameter, the cylinder will be 3.25. And now I can choose one of these and the V key for vertical, but it looks like that over constrains us, so I'm going to hit Control Z and figure out what's going on here. It looks like we have some sort of relation that shouldn't be there. There it is. There's our tangent relation, so we'll get rid of that. And now I can V key to be vertical. So now all I am unconstrained with is this direction. Let's polyline center to center. And I can make these equal. So the only way that we're unconstrained now is by right here. Let's edge import this edge as a reference and simply make that coincident, and we're fully constrained. From here I can add some driving geometry. Primarily I think what I want to do is sketch out, actually you know what, I'll make this for reference as well, but I want to sketch out one of my 4 valve ports. So there's a relation that I can add, we'll make that 0.6, Shift H for horizontal, 0.6. And now I can give this a diameter or a radius. Shift R, that's a diameter symbol, so we'll go with a diameter of 1 inch. So that'll be one of 4 valves. And being fully constrained, I can add my driving geometry. I'm going to choose a center arc. And now I can add another and another and one last one. From here, I'll add in with the H key a horizontal relation. Same down here. Add a vertical with V, and same, although that one might be not needed. In fact, I don't think that was needed, so, oh, but it automatically removed it for me, so that's good. Okay, now polyline, but we'll do a construction polyline. And between these two lines, add perpendicular. Finally, it looks as though, oh, there's our degree of freedom. Let's merge those, and we're fully defined as I expect it to be. So with that being done, let's close that. I want to create another sketch here. Switching back to driving, I'm going to put a rectangle here. What I can do is construction, polyline, and I can reference the center of my rectangle using these relations: parallel and equal. From there, I'm not that much in need to see what I'm doing from here. What I think I'll do is model, go to my pad, hit the spacebar to hide it, and now I can use my edge import tool and import some aspects of this sketch. Namely, these 2 points would be fine. And all I need to do is reference the center, and so in like fashion, equal and vertical with the E and V keys. And that should have us fully defined on these 2 lines. Now I can add in a horizontal relation between these 2 points, horizontal. From here, Shift H, another horizontal, and add in distance of 1.5, Shift V for distance of 1 inch, Shift H, let's say that I want from here to here to be a total of 2 inches. Now I can show my body again and complete that sketch by closing. Perhaps the most graceful thing that I can do, well, actually, I'm going to create another sketch now that I think about this. And this is going to be a reference sketch. So what I'll do is grab my edge import, I guess that will work. I wanted only that point, but that will do. In like fashion, polyline for construction, as we've done before. E for equal, parallel, and we're fully constrained. I'm going to add one driving line. I have to do this in a separate sketch, or it will throw my port off. So with this line being vertical, import this edge, and this is a simple measure to fully constrain. We'll add in a coincident relation. So now the end of this line is dead center to both of these sketches. And now I can create a plane to reference off of it. We're going to say datum plane, and I can select that line, and notice it snaps to the endpoint of that line, normal to that line. So I'm going to say OK. Immediately, I can rename this to be valve center plane. And if I was less interested in time, because this is going to be a long video anyways, I would also rename a lot of these features, but we'll be busy as is. Next sketch that I want to make, another plane that's going to be less significant in the Z direction. Let's go 1/2 inch perhaps. Okay, and with this plane selected, we can create a sketch. I can come over here and immediately hide both of these planes. Now that I'm sketching, let's make this a wireframe and edge import this, and this. And I'm trying to think about what would be fastest, if center point arc is the fastest or something else. But I think this is reasonably fast. I'm simply playing dot to dot and retracing what I've already made, but this is of course on a different sketch plane. Okay, so that's our original sketch. This is the one that we've just duplicated. I can tasks and close, and finally, where it's going to all come together, this is my last sketch. Let's go to the valve center plane and sketch. From here, edge import. I'm going to import some of these points, and I think actually I've made this cylinder head enough to say that this is the most times you're going to make a number of sketches. I didn't want to add that, Control Z, for one feature. So this is probably the most tedious in terms of making the most numbers of sketches. There are a few decently large size sketches coming up, but in number of sketches, this one takes the cake. So E for equal, H for horizontal, and that way I have a center reference. I'm going to do the same. E for equal, H for horizontal. And I already have a nice little reference right there, thanks to my origin. Going back to driving, I'm going to make a line. I'll make another line. And I don't need to constrain the end of that line, even though I have a degree of freedom. And I'm going to do a rim point arc. And I can make that tangent. Tangent. And we're fully defined. So, spacebar to hide that line. And now I'm going to do a reductive pipe. or reductive sweep, depending on what you want to call it. It already pre-selected a sketch for me, so I'm actually going to reject that. Make sure nothing is highlighted, except we'll hide that and click off again. Make sure nothing is highlighted, pipe, and now I can choose I want to start with this sketch. Now I want to sweep to here. So now I actually want to sweep along this path, right? So we're going to say path to sweep along this path, and it shows up. But we want to have a different transform mode, so we're going to choose multi-section and transform into, I have to say add section and transform into this sketch. And notice how it does that, but notice that as we go from one sketch to another, this ends up being very conical, like a cone. We don't want that. We want this to be straight and cylinder-like so that we can add in valve seats. And that's why we've made this second duplicate sketch. So we're going to add section and choose the second sketch. And notice now we are very much like a cylinder, very straight in between these two sections, and our transform happens in between. I'm not doing this in terms of flow, so you may want to modify this face to be flat if you're concerned about something like flow. I don't think it makes that big of a difference, but I haven't flowed this. Alright, we're going to use the spacebar and hide those sketches, and we have our first port. Let's take a look at what we've done by going to flat lines. Now I also would want to make an additional plane, and to do that I have to sketch on this bottom face, and I'll use driving geometry coincident to this vertical plane. And this time I can take a little shortcut, Shift V, and since I know the spacing is 3.5, I can say 3.5 divided by 2 relative to the origin. Again, referencing where our cylinders would be, 3.5. You can make these equal at Shift R, a diameter of 3.25. And then we're fully constrained. So what I want to do is reference the center of the cylinder instead of the center of the valve. And so I'm going to add, well, first off, import the same edge that I always have. And add a vertical constraint. And of course we can make these points merged. So now I've got a line where the tip is at the very center of the cylinder. We'll close. So I've got to do a datum plane. So to do that, I'll select the very tip of this line, datum plane. There we go. So now I've got a datum plane at the very tip of this line that references my cylinder center. And with this plane highlighted, I can create a sketch. And I can immediately go to my model. I can name this cylinder center reference, and tasks close, just to make sure that my sketch doesn't break when I rename it. So now that I can edit my sketch, the last thing I'll do is hide this plane. Since I'm sketching on it, I don't need it. And I can start creating my combustion chamber. I want to start by making a vertical line and a horizontal line. Shift V for vertical dimension, and we're going to make that, say, 0.3 inches. Yep. Now I can add in a 3-point B-spline. I can set these to be vertical, horizontal, and that way we know that that ends tangent to vertical and tangent to horizontal, which is what we want. And then I know my radius, so Shift H for radius. That's going to be a 3.25 cylinder divided by 2, and we're fully defined. So we're going to task and close. And again, nothing's broken up here, so that looks good. My cylinder head, we're going to create one more reference, and we can cut our sketch view. I can run my edge import tool and import that line that I just made, and that way I can reference it perfectly center. Shift V for vertical dimension. Just to fully constrain, we'll go 6 inches. That's an axis. So now that I can wireframe, I can choose groove right here, and I want to groove with this sketch. And then for my axis, oh, it already chose my vertical sketch axis, so I didn't even need to make that, but I can select that reference because I went to all the work to make that. And so what we're looking at now is our combustion chamber. And there's our valve. I can highlight this and hit the space bar to hide it, as well as this. Now let's work on a spark plug hole. So what I can do is sketch on this face, and for the center point I can edge import this, and that's how I know that I'm making relative to the center of my cylinder. Shift R, we can give this something 0.4, maybe 0.375, seems like a nice hole. And you can actually use hole, or you can just pocket through all. It's whatever. And there is a spark plug hole. Now finally, I can reference my very center plane. So if I make sure that nothing is highlighted, I can choose a sketch, I can choose this plane, and I will once again wireframe this. And this is going to be a little bit tricky, and I'll explain why in a second. It's not going to be tricky to do, like as far as being hard, but it's just tricky to do thinking about all the features that we have coming up. The reference, I think, is a pretty good reference. Now notice the wireframe has only one spark plug hole, so this is not a center line. This green is the center line, don't be confused by that. Let's make these equal, and I want to make a profile that matches this pretty well. So one option that I have is to do an arc, and that seems to fit actually pretty well. So what I've done in the past when it doesn't fit as well is I've done two arcs that are tangent to each other, and what I find is that the tangent point gives you two faces, and when you have two faces and you have a feature that you have to extrude to up to next, it messes everything up. And so if you want to do two faces, what I recommend, or to do two arcs, what I recommend to avoid the two faces is to make your second arc. And of course the point of making the two arcs is to make them different values of radius, like what we have here. And you would make a B-spline. Let's say you'd make these for reference so that they just constrain your entire sketch, and then you can do kind of what we've already done and make a 3-point B-spline and make that spline of best fit to what we're doing here. In fact, since I've gone this far, I'm doing it. What I'm going to do is I for now will delete my B-spline and work on just getting these arcs to be a good fit with multi-radius features. Might as well make it technical. Um, 4.75, let's say on diameter 1, and yeah, 7.5, let's do that. And now I can edge import. This way, if I err on the side of a little bit more advanced, hopefully the average user might pick up an idea on how to do something. I don't want to say I'm, teaching some amazing be-all, end-all way of doing things, but maybe it just shares a few more ideas for someone in the future. Let's go with 0.25. That seems a little bit thin. Maybe 0.325. 0.3. I'm going to do that. Okay, how tall do we want this? Shift V, and we'll make that 0.75. I mean, that's kind of thin. I want it to be that thin walled, so let's try 0.7. It's amazing what 50 thou can do. 0.65, and that should be all right. Now I can add a driving line here, and I'm going to add a certain second dimension above the face, and you don't have to do this. I don't even think FreeCAD even has a risk of tripping and error. I think it's just a safe practice, parametrically speaking, for this program. Let's go with actually Shift V and say 0.125 arbitrarily. And now we've got 2 degrees of freedom. They're probably tied up, yeah, somewhere around here. So what's the height of the tangent point that we want? I kind of like what we're doing here, so let's go with Shift V, and let's go with something like 0.45. That's not too bad. So this is the example that I'm going to try to go off with the B-spline. Make a 3-point B-spline, and then I ask myself, where's the best match to the arc? Unfortunately, I can't make this B-spline coincident. That relation is not supported, but that looks pretty darn close for what I'm trying to do. And you notice no matter what profile you have, the B-spline should be able to get pretty close. So let's say that that's our point of closest similarity. I simply constrain the third point, 0.59, and Shift V, 0.76. Oh, and you know what I never did? I never gave that a distance, apparently. Shift H for horizontal dimension. 0.5 is beautiful. Now let's replicate what we have. Coming across, I want horizontal. I don't think it's letting me go coincident straight off. So let's choose a vertical relation. There we go. Now we're on the other side, the easier side, because we've defined everything already. I bet we could do this without doing a single dimension. E for equal. Might as well come all the way down here to this point and make it H for horizontal. Now, you know what? I probably don't even need that. Let's go with our B-spline, make a 3-point B-spline. And now I'm going H for horizontal again. I wonder what would happen. Yeah, I can't really highlight both and say equal. Of course, that really wouldn't copy what we're doing. So, in like fashion, because I want to call out, a center point, you could use the symmetry constraint as well, because I use multiple CAD platforms. The symmetry constraint is so beautifully unique that I tend to use strategies from the multiple CAD platforms that I use, but on a lot of these you can use the symmetry constraint no problem. Got that done, right? We're fully constrained, and because I have a spline, this is one face, whereas the two arcs made two faces, so this spline saves us a lot of headaches later on. That's the beauty and point of using it. It replaces two arcs of different radiuses that are tangent. So I'm going to close that. Now we made this 15.25 inches, and I can go back to flat lines at this point too. Might be better to visualize. With my sketch highlighted in the history tree, let's go tasks, pocket, 15.25. We're going to say symmetric to plane. Of course that cuts the whole thing. So what wall thickness do we want? Let's try 1/4 inch. So we're going to subtract 1/2 inch from each side, and that seems good. You usually say fillets for the very end. I'm going to cheat and put a fillet on this edge. It may or may not be a part of the final design, or may or may not be something we have to reference along the way. But since this is a fundamental shape, it very well could be. Let's make this 350 thou. Okay. Now I'm seeing a little problem here. I should not have that open. So let's go back to that pocket sketch and make one small adjustment. Yep, I can see I didn't pay. Oh, I thought that this, yeah, let's see what's going on here. Okay, so the wireframe, the face kind of has a little hump in it that's a little bit higher. So that's part of just troubleshooting your design. Let's go back to edit sketch. And what would be best to do is probably just manipulate the location of our spline. Let's go with 0.78. Yeah, that's good. 0.85. That should clear it just fine now. Nope. We still got a little bit. Sketch, edit sketch. That's the beauty of parametric modeling. 0.875, and let's reduce this side by something like 0.55. Still there. So clearly that has less to do with our splines now and more to do with this dimension. Let's go with 0.4. That's a little bit better. So now that we've got that done, again, go back to flat lines. It's funner to visualize that way. Are there any other features that we can add? And I say there is. And notice I'm only building part of my cylinder, because the minute that we do a multi-pattern and pattern these things out, I should call it multi-transform, because that's what they call it in FreeCAD. When we do a multi-transform, we are going to hit those rebuild times. And so I want to make as many features as feasible prior to those kinds of rebuild times. So this is just trying to optimize, at least in the beginning, the most amount of performance and rebuild as we can. With that being said, let's take a look at what we're dealing with in terms of our valves. I think that'd be the best thing to do. Let's go back to our valve center plane and create a sketch on it. So I think the big thing here is, yeah, I can cut my sketch so I can see it a little bit more clearly. My big thing here is, can I get my valve to be, this is not a very friendly shape to try to pull the center of it out. So I'll do my best. This, of course, is a conceptual model. Let's draw what our valve axis would be. And I have to ask myself, what angle do I want off of vertical? And so I'll import a reference. You can also use this plane here if you want to. I can say A for angle, and I want my angle to be 5 degrees, right? My valve will be 5 degrees running through this block. What's the center here? Well, I don't know. Why don't I import? And I don't think I can import off of something that I've cut. So why don't I uncut this? And let me import. Oh, these are coming in as splines, but I think they'll at least come in as something useful. Again, let's cut that face, get normal to it. I think that's probably our best bet, to do something like that, to call out what the center is. So I'm going to polyline. And of course this is calling out an approximate center of our valve, because we're running at an angle. So equal, and we're going to select these two and say parallel. I'll highlight this point and choose coincident. So now we're relatively constrained apart from these two edges, which are easy to constrain. Let's go with edge and edge. Horizontal. Horizontal. There it is. So we're going to call that our valve axis, and that looks quite centered. I think we've done a decent approximation of where that's going to land in the middle. Next thing that I want to do is to start looking at perhaps cutting our valve seat, the groove that our valve seat will fit into. For that, I want to use a datum plane. You can see we snap to the end of that line, normal to the axis at the degree that we want. So I'm going to say OK to define that. Of course, highlight and sketch. And my origin snaps to the relative center of where my valve is. That's great. So that's where we're going to do our cut. Now the tricky thing about this cut is as we make the cut, one edge is going to grow thin or the other one does not, and that's because that's where how the valve is going to sit. So bear in mind, it's not going to be anywhere near perfect. Shift R for diameter, and I'm going to make that 1.15 perhaps. That gives us kind of a narrow wall between valve seats, and so you'll get a heat buildup there. I don't think that's a huge deal, but it's something to think about in terms of if you were actually making this. Yeah, I think that's pretty good. Let's go close, tasks, pocket. That is already in the way, so let's hide that. And on our pocket feature, let's bump this up. I went a little bit too far there, so let's try 0.35. That's not a bad valve seat right there. That's actually quite beautiful. Let's see if we... 0.325 is a little bit more of a fractionally nice number, and that seems like a pretty solid valve seat. You've got a pretty decent diameter there. That's better than a lot of past versions that I've done, and this is the first time I've done it this way, and so I'm glad I'm kind of experimenting here. So there's our valve seat. Let's work on or valve, you know, that boss that contains the valve guide. Let's work on that valve boss. I'm going to call it the valve boss from now on. Maybe I'll call it the valve guide every now and again. So let's make a reference plane for that, right? Let's highlight the plane that we've made. Well, maybe I'll call out my plane and then refer to the plane that I've just made. Or not. I'll show it with a space bar. Delete this. Now with it showing, I can reference off of it. So instead of having two planes that are defined by each other, I'm going to, in my Z direction, I can flip sides, and I can choose a height for my boss, right? This plane will define the height of my valve guide boss. And I want to choose, let's try 2.75. I think that would be decent. But let's make that valve guide and see how it looks. I'm going to hide this with the space bar, highlight this, sketch, and then hide with the space bar again. And I love how the origin snaps right on that axis, because now I can define my valve boss just by the origin. So we'll shift R, and I think our spring diameter is going to be the primary definition of what the diameter of this boss should be. 3/4 of an inch is a little bit too large. So I can maybe tone this down to 0.7, still large. 0.5, I mean that's a pretty good option. Those are small valve springs though. So I'm kind of torn. You can always increase the angle, but I'm so happy with how that turned out. I don't want to mess with it. So let's give 0.5 a try. So tasks, close, and then with our sketch highlighted, I can task, pad to first, reverse. There we go. You'll notice, had I had a tangent line running through here, that to first still probably would have worked, but it would have left a lot of liability that something wouldn't match up quite well, because it would reference one face and not both, and with the different radiuses, that paints a picture for problems. I think just to try to maximize what I'm working with, I'm going to go with 0.55. Should I go with 0.6? Let's try 0.6. I really want those to be decently large. It'd be more realistic for them to be large. 0.6 is not bad. I think that's an appropriate height for everything. Now from here, just for grins, I want to check my axis, and that's of course going to be sketch 11. Oh, yes, that will. So I'm going to cut my sketch plane and look at the angle that I defined. It's way down here. If I made this something like 7 degrees, let's just see how everything turns out. Relatively the same. I think this part of the wall is a lot thinner than this part of the wall, but let's just call that acceptable because I like having some room right there. I'm going to sketch on this face now. Oh, of course it doesn't give me that axis anymore, and so I can delete that sketch. It'd be easier to sketch on this datum plane because now I have my axis where I can center off stuff easier and don't have to import as many edges. So valve springs, Shift R, let's go with something like 0.55, kind of a thin wall there, maybe just a straight 1/2 inch. Well, no, that gives us some tolerance. So let's say we could use a 1/2 inch outer diameter spring and have some fudge factor there. From here, let's go 0.25. That's could probably do 0.3 tasks pocket. I was going to sneeze there. Let's go 0.175. Finally, if I sketch on that plane one more time, we can cut our valve guide. Well, a hole for the valve guide. Shift R, 0.25. That's probably too thin of a wall, so let's go 0.2. And then, yeah, let's say you have a valve guide in there and your valve is 1/8 of an inch or something. Let's say close, tasks, pocket, through all, okay. There it is. Okay, so we'll use the spacebar to hide that. I think that's starting to look very promising. Why don't we, I want to say, why don't we start patterning, because we're going to have to do it sooner or later, and we've got a lot of features to pattern. So, multi-transform. Let's think about the first thing that's logical to pattern, and well, perhaps I can start with a simple linear pattern and go with groove, and that will define our cylinders, so we'll be able to tell if everything is good. But I chose mirrored, of course. I meant linear pattern, and we're going to say groove, okay. We, of course, want the vertical sketch axis. We know that we have 4 features that are 3.5, and we have to reverse direction here. Or, yeah, they're 3.5 apart, so 3.5 times 4. That should come out to, I don't know, some distance. Occurrences, we want to have 4 occurrences total. But that length doesn't seem to be doing the math here. Oh, because I'm looking at it vertically at an angle. We want normal sketch axis, 14 inches. Sorry about that. Oh, okay. 3.5 times 3. Okay. There we go. Right, so now we can reference our cylinders. So I should next focus on doing my spark plug hole. So that's going to be pocket. Is that really the first pocket that I've done here? So let's go with linear pattern, pocket. And we're going to use, it should be vertical sketch axis this time. Reverse direction. Yep. 3.5 times 3. And we want 4 total occurrences as last time. And there's our pattern. Alright, let's do the more complicated multi-transform. We've got a lot of that to do. Multi-transform. And let's do subtractive pipe. Alright, so with this subtractive pipe, we want to mirror it to the other side. So we're going to add a mirror feature. We want to mirror it across this plane. And then we want to linear pattern it. And of course our pattern, it could be reference. I want to try the normal sketch axis, see where that puts us. Vertical sketch axis. There we go. And we of course want to reverse direction. Since we were 0.6 in defining our holes, we're going to be 1.2. And there's our 4. Now we want to add another linear pattern. Vertical sketch axis, of course, with the reverse direction, with a length of 3.5 times 3. And that'll put us centered at this end cylinder. It's still calculating the times 3 part here. And we're starting to see those rebuilds. Let's go with 4 and OK. And so we now have been able to populate the intake and exhaust ports for every cylinder. So as you can tell, that was a little bit of a rebuild. These are just going to get longer and longer, so I'm going to start cutting out rebuild time in the edit. So if you get rebuild problems, just let it sit and it will work. It will work. It'll just take a while to rebuild. We got to do the same thing up here for multi-pattern. Let's go with this pad. I want to mirror across this plane. You can see there's our mirror. Now we want to linear pattern the same way that we've done before. We're going to reverse, and now a distance of 1.2. Add in another linear pattern. Reverse. We're going to go 3.5 times 3. That, of course, is 10.5. And we're going to go 4 occurrences. Okay. Now we'll want to transform, multi-transform this hole. So again, we'll open up the multi-transform dialog. In fact, I might want to see what we're looking at here. So pocket 004 is that hole, and pocket 003 is that spring groove, it looks like. So we're going to multi-transform this. We're going to say here, pocket 003, and add a mirror transformation across this plane. And then we can add a linear pattern. Of course, reverse, and a distance of 1.2. Add in a second linear pattern. .5. reverse, we want 4 occurrences. Okay. Finally, another multi-transform, 004, mirror, YZ of course, linear pattern, reverse, we're going to go 1.2 rather. Finally, linear pattern. Reversed. 10.5. 4. And OK. All right. Looks like we've got all that done. Oh, but we have to also multi-transform our valve seat. Multi-transform. This is going to be pocket 002. Add a mirror transformation. There it is. A linear pattern. We want a distance of 1.2. Perfect. We want another linear pattern. 10.5. 4 occurrences. All right. So we've got a pretty decent start on our cylinder head. Still a lot of detail to add. I think I want to sketch on this face next. And I want to sketch a flange that will have some studs. First off, I'm going to actually switch to reference geometry and call out where I want to put these studs. A little big one there. Oops, let's get back into that sketch. Equal with the E key. Now, click on the center points of these leftmost ones. Vertical. Now click on these center points. Vertical. In fact, do these need to be driving? We could probably yeah, we could probably make them driving. So next, let's import a few edges. Actually, I could probably use, yeah, it'd be smart to import those edges. Alright, let's position these. Shift H, 0.25. Shift R. How about 0.25? Quarter inch in diameter stud should do pretty good. Shift H. .25. Shift V now. I did not mean to add that. Shift V. .25. Hey, why is that giving it to me in thou? Thou again. All right, now this is one of the most tedious sketches that we're going to have. All right, and this is not fully constrained. So we need to add a vertical dimension, and then we're going to have a fully constrained sketch. All right, let's actually add a driving center point arc. And I'd actually like to get all my arcs drawn that I want. Okay, so I have arcs drawn without relations. I should also add an arc here. So what I'll do is add relations, horizontal and vertical. Horizontal. And that shows that these are now tangent. Let's give this a radius, or a diameter, but you should define an arc with a radius, so let's change that. 0.25, that makes it a 1/2 inch diameter, so we can add a, and I did not mean to do that. There we go. We can add a horizontal dimension here. horizontal relation with H key. Let's go with tangent. Horizontal. That would be fine to make these vertical. Now the question is, how do we want to constrain these? I'm going to select these three and make them equal with the E key, but of course that appears like it doesn't work. So Control Z. Let's try 0.125 inches, a bit more reasonable. Equal with the E key. So with this part being fully defined, perhaps we don't even need to have these equal constraints. Get rid of that equal in this dimension, and I can simply make this vertical. And now I can simply make this coincident. And that's a better way to define what this radius value is. From here, let's see what happens if I merge these. And it completely eliminates that radius. Okay. So it seems clear. Let's get rid of constraint 37. Now we can get rid of constraint 35, that horizontal, and make these tangent. Now we can overlap these, and that's a better way to constrain it. Now I can spread being equal across all of these. And we're still fully defined in this area. So let's move on to this curve. Of course, it's better to smooth wherever possible as far as design is concerned. So we'll make a sketch fillet in here, and of course use the E key to define that radius. So, in keeping consistent, equal here. And now I just have to worry about this. Let's do the same. Vertical, coincident, adding a sketch fillet, equal. Now we're fully defined at this point. We just have to work our way up again. There's another sketch fillet, equal, and it looks like we have to make this equal from down here. Now, this is the only degree of freedom locally. I'll add a vertical relation. Oh, maybe not, that might mess up applying our sketch fillet, so instead I'll draw a vertical line. Coincident. Another sketch fillet. Equal. Just another sketch fillet. We'll highlight these three, equal. And again, this is our only local point that isn't defined. This is the most exhaustive sketch, I think, in this part. Vertical. Sketch fillet. Equal. And let's add a coincident. Let's make sure that this is equal as well. Sketch fillet. Equal. Equal. Tangent. Now I can make these vertical to make sure that this ends on horizontal. So that's the only local unconstrained point there. Let's move here. And using the same methods. Coincident. Equal. And we're defined. Equal. Coincident. We need another equal relation. Equal. Now we're defined. Equal. Equal. And equal. That's our only locally undefined point. Coincident. Should have the pattern by now. Equal. 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 Vertical. Coincident. Equal. Yep. So we're down to 5 degrees of freedom. Not bad if I say so myself. Make that equal. And we would probably do well to make this point vertical with its center point so it ends on horizontal. And we can probably merge these points. That gives us 1 degree of freedom, probably over here. There it is. Horizontal. And we are fully defined. Now, I want to import edges of my intake and exhaust ports. The idea is to have at least a point pointing out the corner of each intake and exhaust port. Okay, now I can take my corner rectangle and draw from one corner to the next. Now I can close, and I can, under Tasks, pad to a distance of something like 0.25. Now I can orient and save. Okay, with this being done, why don't we sketch now on this face, and we can start working on a profile for our camshaft retainers. What I think I'll do is import this edge here, and perhaps we can sketch out a general profile. I think I'll go with, there we go. Let's go with the rim point arc that we can make tangent. Kind of tricky when you're not really that constrained. And then I'll go with another one that has a concavity going in this direction. We'll make these arcs tangent. And a little bit tricky in trying to get it how you want it. Then I'll make an arc that has a concavity going in this direction. And we'll go tangent again. Now I want to reference the center between the cylinders, so let's edge import here and here. And that gives us arc center points in like fashion. I might even do a point that's coincident here with a symmetric relation. I underuse this relation admittedly, especially for how useful and innovative it is. That's kind of giving me the profile-ish that I want. Now we'll come over here, and finally one last line here to try to start getting things constrained. I'm going to say horizontal, Shift V for vertical dimension, and we're going to call that 0.25 inches. I can make this tangent by taking the center point and the end point of the arc vertical. Now we know we're tangent to horizontal. We've got 6 degrees of freedom, which is actually quite a lot. So I'll import this edge there. Shift H for horizontal, and we'll set this to be 1/2 inch. We need a little bit closer than that. So 1/4 inch away, that looks about right. I'm going to add some reference geometry. Actually, I'm going to add a second line now that I look at this. We'll make these equal. Again, this and this equal. Equal here. I'm going to set in similar fashion. Well, why do I even need these construction lines? Again, I underuse the symmetric a lot, and all I really need to do is choose symmetry here, 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 and now I'm calling out a center point of this imaginary rectangle. Very, very useful. So we care about the center of the camshaft and how it's going to be intersecting with the top of our valve. And that's a little bit of a tricky thing. So what I'm going to do to make sure that I get this right, hopefully at least, is show sketch 11. That is, of course, the axis that we've used on our valves. And of course, it's coming in at the wrong spot. But that's all right. Might as well import it. Using what? How about symmetry? We'll make this coincident. And symmetry, oh, I had something pre-selected there, so symmetry here, here, and oh, of course I have to edge import that. So now symmetry from here, 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 and I need to establish a horizontal as well with the H key. So we'll make that center point vertical with the axis of the valve. That's, again, somewhat of an approximation, but I think it's going to be a good approximation. And let's see, going back to tasks, I've got how many? 4 degrees of freedom, and it's all in here. So I really need to set some radius values. I think it would be rather appropriate to keep this tangent to vertical, so we're going to add a horizontal relation there. We'll bring, yeah, this really is more about radius values than anything. So Shift R, my radius, let's make that, would 1/4 inch be too tight? I'm going to be a little bit more generous. If we call it 0.3 even. Now, the question is, what if I set this and this to be equal? That profile, that looks pretty good. So then I can even define a height, which I think, for my purposes, would be pretty good. That looks really good. So I'm going to say Shift V from this center point to here. I'm going to go with 0.1, right? 100 thou. And that's hard part over. So we'll fill in the gaps vertical, equal, and 3 arcs, equal, vertical, which also is a tangent relation, vertical. I'm not sure if that took or not. I'll try it one more time. Vertical. Yeah, that's better. We'll make those center points vertical. Vertical again. Equal. And we're fully constrained again. And now our last arc. Guess I could do a tangent. Equal. There we are. Looks like I have a redundant constraint. That can be a scary prospect. So we'll delete that. And we're fully constrained, so that worked out well. That looks like a good profile. So I'm going to exit this. Tasks, pad, and we want to say to first. We'll reverse that dimension. There it is. And thus comes the big issue. Had we not used a spline, we would have a tangent line running through here from the 2 different radius arcs that we used. And when I say to first, it would stick to one curvature and not the other. And that can cause some serious problems down the road, or even right now. So that is something to be careful and wary of, but we avoided it by using a spline. Now that we've done that, I think we ought to do another sketch and import some edges. Unfortunately, these will import as arcs and not be splines. And we can create another profile. We'll again go with tangent as before, equal. We'll want to say vertical. And that's the only degree in which we are not constrained. Equal. Vertical. And vertical. And again back to 1 degree of freedom. Equal and vertical, and back to 1 degree of freedom. equal, back to 1 degree, equal, and back to 1 degree. So now, if I do a vertical dimension, and I make this 3.5, I make this equal. Now I can close this off immediately. Just like that. Looks like I have 1 degree of freedom. I didn't snap properly. Close that, and so there's a profile for the center and there's a profile for the edges. With that sketch highlighted, pad, we'll reverse to first. Okay. Now, let's multi-transform these. These are going to be very significant features here. So we'll go pad 3. We're going to add a, if it will let me, a mirror transformation. We'll choose this plane here. Now that we're mirrored, we want to add a linear pattern. Vertical, as always, it seems. We want a distance of 7 inches and 3 occurrences. Of course, we want to have the vertical sketch axis, not a face. Don't know how that ended up there. Okay, with that being done, I'm going to choose OK. And let's multi-transform the next piece. That's going to be pad 004. And we need 2 mirrors. Mirror. And we're going to go across this plane here. And then mirror. We're going to go across this plane. And there we should have a sufficient amount of camshaft retainers. So I'm going to say OK. I like to sketch on this face. To properly see, let's wireframe. Good. So we can observe that this is the wall around our cam retainer, and this is the axis by which we have our valve traveling. And so we can use this to reference the center of our desired camshaft, as we would want it to sit at the center of the valve axis. I'm going to import some edges. Primarily, if I can get to it, this point. It'd also be significant to use this edge as well. Now I can use I'll use a center point arc. We're going to go horizontal, horizontal. I can define a radius. That, of course, is too large. So I'll go with something like that. And I can make this driven, or I should say driving geometry. And draw a line going this way. For design intent, that seems like a relatively short edge. You don't have to do this. It might be a longer rebuild, but as far as I want to, let's take it back to our pad. And edit our sketch. And we can make this a little bit more forgiving, perhaps 0.075. Oh, that's good. Perhaps I'll change that actually to 0.1, and we'll miss the thou and use inches. Finally, I can close, and notice we were able to rebuild fully. So we'll bring up this multi-transform again. And our other features with imported parts have also been able to update without breaking. That's fantastic. So allow me now to highlight the sketch, and under tasks I can choose pocket. And I can choose 2 dimensions. It'd be a cool feature to have one go to face and the other one go to a dimension or anything like that. But I can say, let's see where 13 takes us. Of course, that takes us in the other direction, so I'm going to say 0.5 over here. And the rest of the way, I know that we have 3.5 gaps, so I'm going to say a straight 15.25 inches, which will take us out past the other end. Actually, say 14 on this length, and I might as well go all the way through on the other side, so I'll make that 1, and that will be our point of entry for our camshaft. And I can select OK on that. Orient and mirror. Let's mirror that. And of course, our latest pocket. And we'll want to choose our YZ plane. And OK. Now that we have that done, oil channels are a good thing to get done as well. So I guess I'll choose this outer face, it doesn't really matter. And let's work on getting those oil channels done. Let's import some edges. And again, I can choose a point, width, symmetry. Now I can make a circle. Ask myself, what diameter do I want my oil entry channel to be, so that the we can make the assumption that the can will ride on an elastohydrodynamic layer of oil. I'm going to switch back to inches, and let's say we want a 0.125 inch channel, and that way that gives us the opportunity to hopefully do the same or more size outlet. Maybe I can even go smaller, 0.085 perhaps, 85 thou. That should be good. We'll close that. Sketch on this face. I can edge import of course it won't let me import that circle, but I can edge import these 2 points, and for brevity simply call out the center using a symmetric relation. We'll get normal. And then I can ask myself what path that I want to choose for oil to be supplied from the engine block. Relatively open, but since we're going to be running straight at that center point between cylinders, it would be wise to use the relatively closer out here, as that gives us more real estate for the oil return lines. So let's do that. Get normal to the sketch, and we have to orient. Now, before I fully constrain anything, I'll import this edge, come out to the relative outside here. Again, don't have to worry too much about constraining. Let's do some arcs. Center point is, of course, horizontal with the H key. That clearly didn't snap, so we'll snap these together. Horizontal again with the H key. That establishes a tangency. And we'll add tangent here. I also want these to be equal. Shift H for horizontal. In fact, might as well make these equal as well. Shift H. 0.25 looks fine. There may be some rounding there, so I'm just going to retype it so that it is exactly 0.25. And then I simply have to establish, apparently a horizontal up here, and then finally a length. Or I could do a radius value, but I think a length is most applicable. Shift V for vertical. Let's go with 0.25. Close. So now I can choose a sweep, this profile, and we're going to choose this path. And that's our sweep there. So if I examine this closely, we can see that we're traveling all the way down there. And if I come out here, there's our supply line, so we can conclude that we go all the way through. If we need further confirmation, we can wireframe and see the path. Just like that. Although now that I'm looking at this, I fear that this may interfere with coolant lines, and so we would want to adjust a simple sketch element 0.85. So we'll just have like a little slender movement as we travel through, and that should be a lot more compatible with our coolant channel that we're going to be cutting. I think good rationale for this placement, now that I'm looking at this, is to say we want it just within the bound of the outer cylinder. So I think that's very appropriate placement. Now that we've done that, let's do some patterning again. I want to first add a mirror. We're going to, of course, select the plane we always do, it seems, the YZ plane. And with that updated, let's linear pattern. Let's use vertical sketch axis. Reverse direction. At this point, we'll take 14 inches and 5 instances. Looks like we actually need to reverse the direction again. There it is. Okay. Okay. We can orient and save. Okay, now let's work on getting some of these camshaft bolts, like the retainer bolt holes, cut. So let's sketch on the outer face again. And what I'll do is edge import maybe these two edges here, and that should be pretty good. I'm going to make a point that I can use the symmetric relation on. There. I can make another point. Perhaps I can choose horizontal. There we go. And vertical. Then I can make two more points. I can symmetric these points. We make these equal. Shift R to call out a radius. I'm going to switch this to inch. So it looks like an 1/8 inch fills it up completely. That means that would be a 1/4 inch radius, which is probably too big. So divide by, that should be 0.625. That'd be, well, I want inches instead of thou. But I'm at 0.0625, so if I can get my decimals right, you know, factors of 10 and everything, then that should be fine. There we go. So apparently we've got some degrees of freedom. Let's check that out. Yeah, it looks like this circle has not snapped properly. And now we're fully constrained. So that will be the bolts that hold the camshaft retainer on. I'll do the same over here. Equal. I'll make a point. Hopefully you're thinking, geez, I'm making a really good point. And we're going to use symmetric. This we can say horizontal, vertical. I mean, you can also just make that straight symmetric too. That'd be even easier. Point and point. Symmetric here. Of course, I need another edge over here, so I'll make that horizontal. Equal. Now we're going to close. Tasks, pocket. Let's say I want 1.75 inches deep. And now that's a matter of multi-transforming again. The first thing I want to do is mirror. Same plane. Let's linear pattern. I want to choose vertical. Let's choose 14 inches, 5 occurrences, and OK. And again, I'll orient and save. And what I want to do now is hide sketch 11. I don't need to reference it right now. I'm going to take this to this front view and let's wireframe it and work on some of the coolant channels. You can see I don't see the features on this side as well as I do on this side. So I'll use this side and I'm going to start a sketch. And I'll do that on the XZ plane. And of course I want my coolant channel to miss the other features that we've created and make room for ones that we haven't created yet. So let's import this edge and Shift H for horizontal dimension. In fact, I should draw a vertical line first. Now I want to be able to fasten this head to the block with 1/2-inch bolts. I haven't made that feature yet, so let's make this 0.6 to give clearance for those bolts. So we'll say that that's as far over as I'm going to make that. I want it to be relatively tall so that I can reference freeze plugs as well. So I can also reference our oil supply. I guess it won't import that edge, but I can at least see about where the pipe is. So I can add this way. There's a little bit of a delay in the sketcher, so I'm going to skip recomputes for a little bit more sketcher responsiveness here. The last thing that I think would be good to do, make this relatively tall. I think that's pretty good. Is I'll use my B-spline in similar fashion to how I've used it already. 3-point spline, horizontal, vertical. That looks like an unorthodox but at least efficient coolant channel. So Shift V for vertical dimension. From this bottom face we'll make it 0.225, looks alright. Shift H. And I'll just make it 1. Shift V for vertical. There we go. We're fully defined there. So we're going to, didn't mean to do that. We're going to task and close. Now we're going to be prepared to make this, so I'll say tasks, pocket. And it looks like there's a little bit of a problem here. Why don't we take a closer look as to, oh, nope, there's our pocket. So I thought there was a problem and there wasn't. I'm going to go back to tasks. I guess model and edit the pocket that we've made. We're going to, instead of 2 dimensions, I guess I'll just say dimension. We're going to say symmetric to plane. Our entire cylinder is 15.25. Let's go from the top view. And I'm going to say, good, 14.125 probably is appropriate. And that should be just about right. So I'm going to say OK on that. And really quite a beautiful image that we've created when we look at it in wireframe. Alright, so now that we've got that, let's take a look at wireframing, making sure that our pocket is highlighted. I want to mirror this feature. Let's go across this plane here. There we are. If you can see, we've got the channel now on this side. So I'm going to say OK. Now, I have to select faces with flat lines. So let's select this bottom face and sketch. Only a few edges need to be imported here. I'm going to take this back to wireframe. Let's import this. This seems like we're on a little bit of a delay, so I'm going to head over to the model and skip recomputes. Here, here. Now I'll import this reference right here because that will be a significant point to be able to reference off of that center. And I think we're ready to go. I'm going to use a center point arc. Draw 2 arcs with their center at the center of the cylinder. I can use a rim point arc. And let's use lots of tangents here. Tangent with T. There we go, tangent and tangent. Then I asked myself, what kind of a slot shape would I prefer to have? Let's have the top end of this slot be, wow, pretty lively, huh? I'll use a vertical dimension to help define this. We'll make this, if I made this point 125, that doesn't look half bad, but let's increase it a little bit to 0.175. That looks good. And then that will give us some room to have a head gasket go in there, so it's wise to, have a little bit of real estate in there. Again, Shift V. Let's go with 0.94. Fractionally, that's kind of a weird dimension, but I think it's the happy medium of everything. So now with that being done, center point, and follow the same process. Let's go with the rim point. There's our tangent. That didn't quite work out the way that we wanted it to. Let's see if I can, there we go. Tangent. Tangent here. Tangent. Let's go with equal with the E key. We're going to make these equal as well. We'll choose these three arcs equal. And tangent. There we go. A little screen updating there. And tangent here. And we're fully defined. So we've made 2 dimensions to define this entire sketch. That's what I think to be pretty good. Let's go with center points here. And we'll go with the same process. Rim points. Oh, good thing that gave me a tangent. Go tangent here. Tangent here. Tangent. 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 Good. I'm going to call this equal and equal with the E key, fully defined. Tangent, 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 equal, and equal. And there we have our slots. Pretty great little slots there. Let's go with close. Of course, the screen hasn't updated because we skipped recompute, so that doesn't look like a regular sketch. I'm going to tasks, pocket. Now, if I say to first, maybe I should recompute just to make sure everything's in line. I'm going to change my draw style to flat lines. And again, with this sketch highlighted, tasks, pocket. I want to say to first and see where that puts us. But I can see it doesn't put us exactly where we want to be. And so let's go look at the way that we constrain this part. Under the pocket, I can reference the sketch. 0.225 is what we want, so let's close. Again, sketch, pocket, .225, and there you can see we're going into the channel without any additional cutting. So we're exactly what we want to be. I'm going to choose OK. Now, under Model, I can select Pocket, Linear Pattern, and I can choose Vertical Sketch Axis. Now I can choose something like a length of 3.5 times 4. It should be times 3. Let's go 3.5 times 3. And we're going to say 4 occurrences. Okay. All right. So we've got the coolant channels cut. We have a decent amount of features up top, starting to look like a cylinder head, but there's still much to be done. I'm going to orient and save. Alright, speaking of wanting to do the bolt holes, I'll grab this outer face and sketch. Now I'm going to wireframe this again, and that way I can start to import the more important dimensions that I'm going to be dealing with. Primarily, I like to import my coolant channels that I've just cut. So there's the edge of my coolant channel, and there's the edge of my cylinder head. I would be most wise to start down here. So let's make a reference circle. I can make this tangent and tangent. I can also import this edge, and that way I can find kind of the center feature, and I'll be bolting it down as far away from the combustion chamber as feasible. Now I'll add a point. I can add a symmetric relation. From here, horizontal. And now let's make this a 1/2 inch. Shift R for radius. Radius of 0.25 is a 1/2 inch, so that gives us a decent amount of wall thickness on each side. If I do the same thing on the other side, it can save another feature, which will increase rebuild performance, and I can go to the extreme and do it a lot more than I currently have, but for the sake of time on this video, I'll only do a few rebuild optimizations because they take time too. Let's go with tangent. In fact, it if I don't even want to import these edges, I always tell you how much I use the underuse rather the symmetric relation. So let's use that instead. It's a good exercise. So I'll make a driving circle. I'll make these two circles equal. I can snap a point onto my plane here, horizontal. So now I know I'm at the right level, and under symmetric. We've positioned our circle the same way. Okay. We can close, and under tasks, pocket. You can use hole as well. Through all. Okay. Looks good so far. Let's take it to flat lines. And I don't see any interference in that hole so far. We are kind of tangent to that edge, so that makes it a little bit awkward, so we can work on that later. Let's orient and pattern. I can do a linear pattern instead of a multi-pattern because I drew that second hole. We're going to go with pocket 009. Alright, now I can choose vertical. I'm going to go with 10.5 inches. I actually probably should go with 14 now that I look at it. Finally, 5 occurrences. Alright? Okay. Alright? Alright, why don't we start developing our coolant channels. I'm going to wireframe again, and let's go to the top view. One thing that I'm starting to see is that the end of this is going to intersect with this oil supply line. So let's remedy that. I'm going to adjust this. I think we're on pad 003. Alright, pocket 007 is what we want to adjust. And notice we're at 1.18 feet. That's around 14 inches, so why don't we make this 14.25 inches. And that puts us a little bit ahead. Let's add another 1/4 inch on just to make sure that we clear that. Yep, now we've got plenty of tolerance. So 14.5 inches is what we want, and okay. If I orient and come around to the back end here, let's make something that joins our two channels. So let me show my other channel here. So now I've got my channel here and my channel here. I want to bring them into one and have an output. To do that, let's create a datum plane, and I'm going to define this plane on 3 points. Here, here, and here. So they're fully defined, attached to those 3 points, and now I'm able to sketch on that plane. So with my plane highlighted, sketch. I really only need to import 2 points. There and there. Also, I like to hide my datum planes. I don't need to directly reference this anymore. There I've got a fully defined sketch. I can go back to the top view. And let us tasks close, tasks pocket. Again, back to the top view. If I extrude this 0.35, let's see where that puts us. Gives us an awfully thin wall. So I'm going to go with 0.25. Now I can orient again. And looking at this, looks like we've joined successfully. We can add fillets to make that a smoother transition, and we of course add fillets at the very end. I can go back to flat lines now. I'm going to sketch on this face. And now with this face selected, I want to reference internal features, so back to wireframe. I want to import this line. And that. Now if I draw a circle right on that plane, so I'm coincident by the center, we'll add a tangent relation. Tangent relation. Now, apparently I had the wrong number of objects selected there, but there's tangent. I'll make that for reference. You can also use a point with a symmetric relation, which would be a great idea to do because it eliminates entire sketch elements. So just as an example of the alternative, which now that I look at it I think is better, these darn habits from other platforms, I'm going to grab symmetric here, here, and here, and notice we're automatically centered. Now I can shift R to call out a radius. Let's say I want a 1-inch outlet, so 0.5-inch radius. Quite large, but good for flow. From here, I'll give this an inner diameter. You might want to do some kind of standardized schedule thickness or something like that, but from here I'll just give it an arbitrary dimension, in this case 0.45. We'll merge the centers. So we'll close and pad. So let's give that a dimension of, say, 0.5. That's still pretty small. We want enough to get a hose around there. Perhaps an inch. If you were really creative, you could put a barb on that face so that it'd be a little bit more realistic for a hose, but I think that's not bad. Now, let's add a fillet. And to better see what we're doing, let's go with 125 thou. Let's sketch on this face. To save from dimensioning, I'll import my ID. We'll draw a circle. And as I cut to my sketch, we'll add an equal relation. We'll close. Let's see what happens if we pocket to first. And it looks like we've done it. I can see the back wall of my coolant channel there, so I'm going to say OK. OK, with that being done, I'll orient and save. Okay, let's make the bolt holes for the cylinder head now. In fact, before I do that, I want to make a minor alteration here. So we'll sketch on this face. And let's repair this area so that will be good for our cylinder head and valve cover and everything else. And this can be done quite simply. Perhaps I'll import this here. I can import this edge, and I can make an arc. Vertical equal. I'll add a tangent simply by making these vertical. I'm going to import this side as well. We'll add a coincident. There. In fact, I'd be better off with polyline. And there. Let's do the same over here. And it is taking a while, so skip recomputes for now. Alright, you can make these two ends coincident. Oh, and it's kind of difficult to change concavity, so let me correct that. That's better concavity. We'll make that tangent vertical equal. There we're fully constrained, just like the other side. Polyline. Looks like I've got a redundant constraint. And wants us to remove 22, which doesn't exist. Let me rebuild that. Now we're under constrained with a degree of freedom, and I've accidentally exited my sketch. So let's get back into it. Yes, we should add a horizontal here. And now we're fully defined. So I'm going to close, and with that sketch highlighted, we can pad to next. Or to first. And I can reverse that. Oh, and it looks like only one of our sketches went through. Sometimes I forget you might be limited in your ability to extrude from two sketches at the same time. So I'll just multi-pattern it, I guess, once it's done thinking. Alright, perhaps we can mirror. Let's go with the YZ. Now that we've got that done, we're going to mirror another time. Of course, choose the XZ plane. And we're good. Alright, with that being done, we're going to be good to add those bolt holes like I'd said before. I'm going to put on a sketch. I'm going to change this now to wireframe. Now I can import a few edges. Primarily concerned with my coolant channel edge and this top edge. Doing the same on this side as well. Now going to the top view. I want to import that imports in half, which actually works to our advantage. And I think that's all we need. So going to construction geometry. Tangent. Tangent. Horizontal. Now I size this for 1/2-inch bolts. I have relatively thin walls, but it should be fine. Shift R for radius. 0.25 is what we want, and so that's our wall thickness. Setting a reference circle. Tangent. Tangent. Horizontal. Equal. You can use whole, you can pocket through all. Okay, now we're going to go through linear pattern, pocket. Let's use vertical. Now I can choose 14 inches. And I want 5 occurrences. All right. Now we have bolt holes going through the cylinder head. For that many, 1/2 inch is a little bit big, so you can even go smaller than that, but that should work. So we have some decent progress. Now I'd like to make some holes for the valve cover as well. To do that, let's sketch on this face. Okay, so on some valve cover designs you have your gasket groove and the bolts are on the inside of the gasket groove, and that's what I'm going to be going for on this one. So I'm going to get started by importing some edges. Probably these. And these sketches really are taking a long time. I'm going to skip recomputes again. Okay, probably, yeah, these up here. Due to symmetry, I'll probably put some valve cover bolts over in here that won't pattern like the rest. Let's okay, now I can go Shift R with 0.125, so 1/8 inch bolt shaft. We'll do a horizontal dimension. .25, that's a little bit small. 0.175 is a bit better. I'll add a vertical dimension here of 0.75, looks fine. And then our groove can go right by this. Okay. You can add a point with a horizontal constraint. And a vertical constraint. Add a symmetric relation. And equal. Pocket. And if I said to first, let's see where that takes us. Not that far. Dimension is fine. We'll go 3/4 of an inch deep. Now I can multi-pattern that, and you can see our gasket groove has a clear route around everything. This design puts the head bolts on the outside, which might be handy in some applications like military erasing. We'll multi-transform our latest pocket. I want to mirror. We'll of course use the YZ plane. Now we'll add a linear pattern. Let's go vertical. I'm going to make this 7 inches. And now we want to have 3 occurrences. And OK. Alright, so we've got our valve cover bolts all done. I want to handle the last valve cover bolts. I'm going to make a separate sketch on the same face. And let's skip recomputes again. This should be relatively easy. Let's import here and here. And now I can add a point and of course orient the point with vertical and horizontal. Vertical here with V and horizontal with H over here. and fully constrained so far. Now I can choose vertical and symmetric. Finally, equal. And we've got a fully constrained sketch. Tasks close and pocket. This time I'm going to choose up to face. And we can choose that face. There it is. Okay, and multi-transform. We'll choose pocket. And now we only need 2 mirrors. First, we'll mirror across this plane. And then I'll say second mirror transformation. And I can choose now this plane. And OK. So we've completed our valve cover bolts, orient, and save. Okay, I want to focus on doing a weight reduction cut. This is, I think, another sketch. It takes a little bit of effort, not too bad though. First thing I want to do is import a few edges. And these circles to reference their center. Fantastic. I'm going to cut so I can see what I've imported a little bit easier. And I'm going to start with the center point arc. So of course we'll set these to tangent. We can set this to horizontal. We can also set these 3 to horizontal, and that ensures that our profile stays concentric the entire way through. Looks like it's asking us to remove constraint 6, and that doesn't exist, so of course we'll rebuild. Alright, let's Shift H with our 1 degree of freedom, and I'm going to say 125 thou perhaps. And now, again, skip recomputes. Let's go import a few more edges so that we can reference some more centers. Or in fact, I don't even know if we have to do that. We can just use some well-placed relations instead. We'll take a line and vertically come down here. Another arc center. These 3 points. Of course, we'll maintain it horizontal. Equal here. Equal arc length. And then I can simply add a vertical relation. Another arc center. And of course we'll add a vertical relation. Another arc. Another vertical relation. An equal relation. Horizontal relation, and that makes us fully constrained again. Come on, how do I get this line end right here? There we go. We'll merge and add a horizontal relation. There we go. That would be my phone. Add a tangent relation. And I think our only degree of freedom will be here. That can be remedied with a vertical relation. And you can see the pattern as we go. So again, horizontal and tangent. For good measure, we'll do an equal relation. And this will be our last hump to get over. Tangent equal. So that's our only degree of freedom apart from the length of the line, which I can solve with this arc. We're going to choose vertical, tangent, equal, and fully constrained. And we'll add a horizontal here. And finally, we'll make sure that this is equal and tangent. Come on, mouse. Okay, that was our last one. If I make this equal, that probably extends too far. So let's go back to tasks and end constraint 45 and find another way to constrain this. How about I edge import this so that I can call out a center point. Oh, and this is, let's do a rim point arc. Let's do two arcs of different radius values. This arc, of course, will make tangent. Make vertical here. Make sure that this is vertical. And now, as far as the length of the line is concerned, if I can select that midpoint, oh, I think I had it. I just had to do a box select. We'll add in a horizontal. Looks like constraint 49 over constrains it, which is strange because it shouldn't. Alright, so we'll make this horizontal instead. I'm going to recompute just to make sure that everything is still kosher. And yeah, we can move around there, so let's try to constrain that one more time. There, selected. Horizontal. That's better. Alright, with my 2 degrees of freedom, Shift H for horizontal dimension, and here, let's go with something like 0.275. And we'll go distance here of something like 0.125. And we're again recomputing in kind of a timely way, so let's skip recomputes. And we'll come all the way up here. I'm going to be even more simple on this and say H for horizontal. Tangent. And there we have it. So that's our sketch. Allow me to orient and close. I'm going to go on now and let me recompute so I can see the full sketch. Sketching on this face. I'm going to edge import this line, and let's trace it dot to dot. Now let's groove to do our weight reduction cutout. But I think it's got the wrong sketch selected, so let me come down and select sketch 32, groove. Now let's specify our own reference. And I'm going to select the line that I just sketched. And don't worry that it's adding solids, we're just going to specify 90 degrees. Okay. Now you'll see we've hit a bit of a hollow point where a bolt hole goes through. That's okay. We can remedy that easily. So now that we have that done, it's time to do a few mirrors. And I've put these mirrors off in this video, if you can't tell, because of rebuild times. This will probably add to our rebuild times. But first off, I'll just cancel this. We want to mirror this flange. And I can hide sketch 33, but we want to mirror pad 002. And we'll want to mirror across the YZ plane. Okay. Now let's mirror the feature that we've just made, groove, and we'll mirror across the YZ plane. Okay. Okay, so now I can orient and save. Alright, let's get started by sealing up some of these holes. You can see we've got our bolt tube exposed here. We can clean that up pretty easily. I'm going to sketch on this face. We'll start by selecting this hole. For ease, I can import this edge and set a tangent relation between the two. And now I can close, and on tasks, making sure that I have my sketch highlighted, pad, and I can choose something like up to face, many options that you could choose here, and this is the face that I'll select. As you can see, we're able to rebuild that wall. Relatively thin wall there, but I don't think it matters for this intent. Okay, with that being created and my pad highlighted, I can add a multi-transform feature. I can add a mirror transformation here. I can choose the YZ plane for mirror. With that mirrored, I can add a linear pattern. Now I can make this vertical. I can reverse direction. Well, actually it looks like I need to reverse direction, and then we'll set the length to 7 inches. Now I can make this 7 and 3 occurrences. And now I can orient and save. Okay, why don't we work on the oil return channels? To do that, I will need a plane, and I don't think I've got one that's where I need it, so I'm going to sketch on this face. And due to the length of recompute time, I'd probably be okay to stop recomputes on this as well. Looks like we're going to skip recomputes on that body. So now on this sketch, I'll import that edge there, which is exactly what I want. And now for good measure, well, I don't even, well, yeah, I'll import this edge here. And close. And I'll come down here. I'm honestly not seeing sketch 30, oh, because I have to recompute, of course. So let's see if we can generate sketch 35. There it is. Now let's make a datum plane. And there we go. So that will be our datum reference where we can see dead center on those cam retainer brackets. And I can rename to, how about, oil return reference, and with that we'll sketch. Let's cut. And of course we're looking at the cylinder head upside down. Let's hide the plane and import some edges. Of course edge import doesn't like importing those. Let me go directly to the back here. There we go. So I've called out the center, and I can call out this back edge as well. And getting normal, we want to create a sweep path, much like we've done with our supply. So I'm going to create two vertical lines and make them equal. Let's go with center and, 3-point arcs or rim point arcs. Tangent, tangent. And tangent. This is not really concave in the right direction, so I'm going to make sure that that ended up working out. I'll go tangent here. And now, of course, that tangency didn't work out. Really, we want the center point on the other side, so we'll try that one more time. That's got the right concavity. Tangent, tangent, equal. Now we're going somewhere. So the question is, how far off-center do we want to be? And we do want to be decently off-center. So Shift V for vertical dimension, and we're going to give that a straight 0.125 is probably good. And we want to move. It's giving me some trouble. So let me get back to the sketch, and I can add a relatively horizontal kind of arbitrary point. We'll make that 1 inch. That's a little bit too far. .5 is too far the other way. Happy medium, 1.25. There it is. So, tasks close. Now I want to sketch on this face. Let's wireframe so we can see our previous sketch a little bit better. And what I want to do is import that center line there. With that imported, I can get normal to the sketch and decide what size I want my return to be. With the help of Shift R, we can go with something like 0.25, which I think that's double the size of each of these two, which is pretty good. Let's close that. I think we're going to be all right to change our draw style. So let me hit the rebuild button, which should get the sketch looking right. There we go. Under part design, we're going to say subtractive pipe, or also known as sweep. And we're going to choose our path to sweep along this path. That might be a little bit large for our combustion chamber. We'll take a look. Yeah, decently large. And that's a lot more than twice as big, so we can afford to go a lot smaller on that. So on sketch 37, edit, and let's say something like 0.175. And that should give a sensible amount of distance for the head gasket. This looks like the smallest amount of distance from the end of the head gasket to a feature, and so that's quite reasonable. What I want to do is multi-pattern. So I'm going to highlight my subtractive pipe, multi-pattern. And right click, add mirror transformation. Here. And now with our feature mirrored to both sides, I can, well, after it's done thinking, I can continue. Right click and add linear pattern. I want to change, of course, to vertical. Okay, I can set the length to be 7. And actually I should make it 14. Alright, we finally want to have 5 occurrences. Now I can orient and save. Now that we have a reasonably complex model, I want to go over making some freeze plugs. I'm going to do so by sketching on this face. And let's begin by, of course, blocking recomputes so our sketch goes a little bit faster at some peril. I want to import some references, and it can help to wireframe this. There I can see my coolant channel internally, and so I'll import the lower edge of my coolant channel, and you'll be able to see that the upper edge of my coolant channel up here extends too high. It's higher than we want to go, so I don't need a reference off of that face. So I'll complete by importing that edge as well. And I think actually as an additional reference I'll import this center line in between, dead center on the combustion chamber. So with those 3 points I can constrain a circle. I can run tangent, tangent, coincident, and we should be done there. So I'm going to close, and in tasks I can pad and change to flat lines, and I want to choose up to face, and I can choose that internal face from the cooling channel, and there is one freeze plug port that should work quite well. So I'll say OK on that. And I would probably be wise to multi-transform that now. So I'll start by making sure that I have the right thing highlighted. Pad, multi-transform, mirrored transformation. We're going to choose the YZ plane, and you can see the reflection there. So now all we have to do is linear pattern, and we want to go 2, 3, 4. So a distance of 3.5 times 3. We'll add linear pattern here. And we're on horizontal. We of course want vertical. We want reverse direction. And we want to update that to 10.5. And finally, we want to have 4 instead of 2 occurrences. And with that, we can say OK. So with that being done, I'm going to recompute everything. And now I can orient and save. With that being done, I can sketch on the face of my freeze plug port. And of course, it's already taking a while to sketch, so why don't we skip recomputes to make sure our sketch goes a little bit faster for the purposes of this video. And I'd like to actually, before I start, import edges. That should import as an arc so that I can reference the center of my port quite easily. I can even, if I want to do something without dimensions, simply make this tangent, and that might be an acceptable dimension for my freeze plug port. I actually think I will add some dimensions. And that way you can say, well, I want to use this size freeze plug, so 0.275, let's say. And now I can also extrude to face, but this time extrude cut, which I think in here we call pocket to face. There's the face I want. Okay. Now I just have to orient, and I'll make sure that I've got what I want highlighted, that pocket, and to make sure that it's recognizable, I'm going to recompute. Okay, with that recomputed, multi-transform. And why don't I add in a mirror transformation? Now that we're mirrored over, oh, I guess we're not mirrored. Let me grab this YZ plane. Excellent. Now let's do a linear pattern. We'll want to, as always, go from horizontal to vertical. I'm going to reverse direction. I'm going to move this 10.5. And now I can assign this 4 occurrences. Okay. So those are the freeze plug ports. Let me orient and save. Let's work on our spark plug tubes. The idea is the valve cover would have a tube that would come down and seal this off from the oil so that our spark plug doesn't get oil and short out. So let's reference the cylinder center plane. That'd be here. And with that selected, I can make a sketch. I can cut away on my sketch plane so I can see things a bit easier, and now I can hide the plane I'm sketching on to make things a little bit more clear as well. I'm going to start by inserting some edges. I don't think it'll let me select that edge because it's not actually an edge. It does let me select that line, which is just as good. Let's get normal to the sketch plane, as this will be a rather involved sketch. I also want to skip recomputes. I'm going to add some driving lines here. I want to make sure that that has the horizontal relation. I'd probably do well doing polyline here, but oh well. I'm going to do vertical. And I can take this edge and say vertical. From here to here. Now I can choose a thickness, horizontal. So that's 80 thou right now. How does it look at 120? Oh. Of course I did 0.125, let's do 125 thou, which is an 1/8 inch. And that looks well for my needs, I think. Maybe 0.135. So yeah, that's not bad. We're not constrained this way either. Shift V. 0.75. Wow, I stretched that about perfect. So we'll go with that, and I'm actually going to get rid of this line. And the question is, what did I just unconstrain there? It would probably be the position of this. So I'll add an equal relation and grab my polyline, and let's set up for a double static O-ring to seal the spark plug tube between, the valve cover and the cylinder head. There we go. I have to add a bunch of relations now. We'll merge these and make this vertical, 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 horizontal, 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 vertical. I think those are already vertical, so that was automatically removed. And it looks like I need to remove constraint 31, which doesn't exist, so I'm going to recompute that. And now I want to add in, and make sure, yep, we've got some degrees of freedom. Now we're going to go vertical. And of course, every time I recompute, it marks it as recomputing, so why don't I say model skip recomputes now that we resolved that. Let's make this equal. Shift V for vertical dimension, and let's give that something like a straight 100 thou would be fine. And I can make these dimensions equal. And just to make sure, I've got these equal as well. And I have only a few degrees of freedom left. You can actually access a free Parker PDF on actually dimensioning these things for static O-rings. Highly recommend it. It's a great resource. I'm simply making a placeholder or something arbitrary. Let's go with 75 thou here. And horizontal, this should be our last dimension before we're constrained. We'll make that 50 thou, and that way you'll get some O-ring compression in there. So let's close. I want to see if this axis is recognized when I go to revolve that. I'm not sure if it will be or not. I think it will. So revolve, and it wants us to revolve around the vertical sketch axis, which I don't see happening, so let me just recompute to make sure that we're dealing with the latest and greatest. Revolve, sketch 40, and it did recognize. Very good. So okay to that. And now I can orient and proceed towards a simple linear pattern. So with my revolution highlighted, linear pattern, and of course I want to choose vertical. I guess in this case we want normal because of the way that we made our sketch. And reverse direction. I will set this to be 10.5. And finally, we're going to go with 4 occurrences. And so you can see we've got our spark plug tubes there, so we're going to say OK. And orient, and save. And now I think it's time that we do a weight reduction cut. I think this wall is a bit more thick than we need, so let's sketch on it. And I'll intend on making some weight reduction cuts, as well as I'm going to start off by thickening this a little bit to kind of pronounce the cam guide that we have. So convert, and obviously that's taking forever, so I'm going to skip recomputes. We'll convert this edge, make these equal. We'll make these arcs equal. Add a construction line here that I can make vertical and equal, and that way no matter what I do we'll always have equal distance. Now I just have to add some dimensions. Shift H will make this something like 0.25, and we're fully constrained. I simply need to close the profile. I think we're fully constrained. Let me recompute to make sure. And it looks like we've got an overconstrained sketch. I'll remove constraint 25. And now it says we've got 1 degree of freedom, of course. So what I'll do is I'll use a coincident relation. Alright, I guess I have to select this stuff first, and now coincident. Nope, that still didn't go. So with my 1 degree of freedom, try constraining in a different way, and this time H for horizontal, and that seemed like it went through just fine. I'm going to close and pad. Let's go for 1/4 inch. That maybe an 1/8 inch would be a better size. That should work fine. Now I'll sketch on this face again, and we can do a little weight reduction cut. Let's make a bunch of rectangles. And if we're going to take that long to rebuild within the sketch, let's skip recomputes once again. Let's make these 3 equal, and these 3 equal. Let's do a horizontal dimension of 0.25. Let's make these points vertical, 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 equal, horizontal, 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 horizontal. Now I can start importing some edges. Adding more dimensions. That's not that bad. And adding horizontally. Make this 1.5. 1, and I think we've probably only got 1 or 2 degrees more freedom. Overall height, yeah, so 0.6 it is. Although I should recompute before going further. Highlight my sketch and recompute. Now with that highlighted, I can tasks and pocket. I want to wireframe that to get a better idea of how deep I'm going. That seems relatively deep. I'm going to go 0.125 instead. That should take us about halfway. And okay. Now I can orient and go back to flat lines. That looks pretty good. I want to reduce a little bit of material in between these ports. I can sketch on this face. Make that vertical, and if it's taking this long, again I'll turn off recomputes. Make that vertical. I want to center this, and there's a lot of different options on how. Right now I think I'll use a construction polyline. We'll set that to be equal. 0.65 seems all right. And orient. Tasks, close, tasks, pocket. And maybe I can say reversed. There we go, with the dimension of 0.2. Perhaps I can lengthen that to 0.25, the thickness of the flange. Now I can multi-pattern that, so making sure that I'm properly highlighted. Multi-pattern. I can mirror. And of course mirror over the YZ plane. And now I can linear pattern. We'll change to vertical. Now I can make my length 7 inches. And I can reverse direction. Finally, we'll make 3 occurrences. Okay, and I'll recompute. And I will orient and save. Okay, I want to start making the studs for the manifolds that are going to go on the side of the cylinder head. Let's start. I'm going to select this face to sketch on. And I've actually already noticed that it's taking a bit longer to make a sketch. So once we get in the sketching environment, I'm going to skip recomputes. There we go. First thing I'll do is import some edges, so we'll be able to locate the center of each stud. Now I want to draw circles concentric with the edges that I've imported. Now I can highlight every circle. I can cut on my sketch plane, and with one edge highlighted I can hit the E key for equal, and all of these create a fully defined sketch. So I can close, tasks, pad, and I'm going to go a distance of 1.75. That looks pretty good. Didn't seem to pick up on my 0.75 though. And with that I'll say OK. So that's the extrusion. I want to mirror that. I'm going to choose my latest pad. And I want to choose my YZ plane, of course. And there it is. Say OK. I'll highlight this and recompute. So with that being done, I can orient and save. Now I want to shift gears and make a gasket groove. This will be the gasket that goes between the cylinder head and the valve cover. I'll sketch on this face to begin. Okay, in this sketch I'm going to import some edges, and this will be our last large sketch. So I'm going to take every bolt hole on one side, and the purpose of this is to reference the center points. Now with these edges imported, I can begin sketching by adding some additional references. Polyline. Actually, I'll just go with a point and we'll make it coincident here, and I'll add in a symmetric relation. So now we are centered. However, looking at this symmetric relation, I am really thinking that I would rather be a little bit closer to the edge over here. So, these two highlighted, we're going to say coincident. Shift V for vertical. Let's do something like 75 thou. Might be a little bit on edge, maybe 100 thou. A little bit off kilter is perfect. I'm going to add in this line, but immediately make it for construction. Shift H. We'll go with something like 0.125. Now I want to add in a center arc that we can make relatively large. Shift R. We'll do something like 0.4 is a little bit 0.45 looks okay. Adding another arc. Tangent. Vertical. I wonder how this would look if I set them to be equal, and of course that's not feasible because I have crossed over a place where there's no material. Oh, but one thing I forgot to add is a simple line without a constraint. And now I can simply say tangent and vertical. Give this a radius value of something like 0.2. Maybe I can buy up a little bit more real estate with 0.3, and I can add a fillet in here, and that should work fine. So, with that sketch done, or that part of the sketch done, I think my last degree of freedom is here, and I can easily solve that with another arc, tangent, and we can make that horizontal. And there we are, fully constrained with a very nice profile. Okay, I can add in a line, and you'll start to get a huge idea of just how repetitive this is. We're going to merge these points. We're going to set a horizontal constraint, and using a center arc, tangent. You can probably hear my wife talking on the phone. I don't know what conversation she's having, but I bet it's pretty interesting. Well, now I can, didn't mean to exit the sketch there. Old habits from other CAD programs. Let's grab this arc and say equal. And of course I have an over constraint of 26. I only go up to 25, so let's ignore that and say equal and equal. Okay, that checks out. So that's my last constraint. We're going to make that horizontal, and we're fully constrained. Now I have the luxury of saying equal. And because I've made it equal there, we've already predetermined the radius of the arc. And we can do the same with the next arc by making it tangent. So again, our only degree of freedom is here. And I can do the same I have to merge these points. I can do the same by setting a tangent relation, and if I say horizontal, we're fully constrained. So we're kind of cruising, but it's somewhat repetitious to make this sketch. Again, equal. Better merge those. Alright, we're going to make that tangent and horizontal. Looks like I better merge those points. And we better make that tangent as well. Okay. We're going to make these equal. I'm not convinced that those have merged together. I guess they have. So now tangent let's go with the same profile as above. Grabbing the endpoint, we're going to say vertical. And now I can choose this arc. And we're going to say tangent. And tangent. Oh, we better merge these points. I was right, they didn't merge. Now I can choose equal. Of course, that apparently grabbed a relation. So this arc and this arc equal. And there we have that. So close that. Now I can recompute, and that will finish up the sketch. Okay, let's take a look at this feature. We're going to look at pad 006. I think I'm going to edit this. It will be less sightly, but a lot more useful. Okay, with that, I want to make sure that I'll skip recomputes and finish this up by drawing a line there and simply adding a constraint to be vertical. Oh, but apparently we've got some inflicting constraints. I guess it's already preset. I just need to have a horizontal constraint. The other thing to do is adjust this side. So again, just in case something happened, we're going to skip recomputes and delete this. Vertical, and simply draw a line. And snap. Okay. Okay, now this will be kind of a longer rebuild, but we will close and orient, and now I can rebuild. Okay, after this very simple alteration, you can see that we have a far better profile to run a sweep with. And it propagated back to all four corners, and we have no rebuild errors in the history tree. So we're doing quite well. I'm going to show the rest of the features, the spacebar of course, and I can focus on doing a sketch to complement sketch 45. So create a sketch on the YZ plane. Okay. And can take an import tool and import that point, which would be very important to us. Add a horizontal line, and just to speed things up, I am going to skip recomputes. We'll add a symmetric relation from this point to this point to this point. I'm going to do a center arc, and of course start on one point and go towards the other. We can cut the sketch plane to see a little bit more clearly, and at this point I can get normal to the sketch axis. Let's go Shift H for a horizontal dimension, and let's make this relatively small. Let's try point 0.075. And then for vertical, Shift V, I can grab this point and this point. Oh. There we go, and I can make that, say something like 16 thou above. Now you can actually dimension this. Again, I recommend the Parker Gasket Sizing Guide. It's a free PDF that you can find with just a Bing search or a Google search. And it's a great reference on actually dimensioning both static and dynamic O-rings. We're intending for this to be a swept feature that you can fit in a preformed O-ring if you like. Now, I'm going to tasks close. Let's wireframe this for a moment so we can see all of the features. And of course I need to recompute so I can actually see the sketch. Let's recompute here. And now that we're fully recomputed, I'm going to highlight my sketch. I've got it highlighted here in the history tree. And let's do a reductive pipe. So we're choosing this profile, and now I can go back to shaded, or even better, as is. And let's choose object and this path. And we're back to the wireframe. So heading on back to shaded, I can even, as is this, that's even better. Looks like we've got a great groove that we can stick one of those preformed O-ring gaskets in. This is probably smaller than realistic, but this is simply a principle or a concept. So this is just a way of doing it, not really a fully debugged design or model yet. Like the bolt that would go here would probably be a little bit close to interfering, but overall not bad. So with that, I can hide my plane with the space bar. And now I can orient and save. Okay, I'll hide sketch 28 again, and then I can choose a mirror function. And of course I want the latest subtractive pipe. And I can specify the YZ plane as my mirroring plane. And OK. And orient and save. Alright, now I'd like to do some fillets. Since we're nearing the end of our design. And in fact, you know, maybe before we do the fillets, I'm going to do a cutout on this bottom face. Alright, so sketching on this bottom face, I'll edge import here so I can, oh, but that came in as a B-spline, so never mind that. In fact, while I'm at it, let's skip recomputes on this sketch and get rid of this. Let's import this edge, and now I can reference the center of my cylinder. I'll also, I think it's a good idea to import this edge here, and I'll start by creating a center arc right around here, right? So this is a little bit weight reducing. Maybe I'll scoot this guy back a little bit, and I'll get out a 3-point. I'll go with tangent and a vertical here. Doing the same. You know, it would make for rather interesting geometry. You don't have to do this at home if you don't want to. Well, of course you can do whatever you want. You just chose to watch this video, but I'm going to import these two edges and reference off of that center as well. And I think just to give the design a little oomph, I'll do a center arc from here out. So it kind of hugs that bolt a little bit more. And I'll do the same over here. Now let's add in the same constraints, but I'd probably be most smooth to make a tangent relation here. And make sure that we're tangent here. So I'll get rid of this vertical. Make a tangent. Set these to be equal, and we'll set these to be equal. Now I simply have to give this a few radius values. Shift R. We'll go with, how about 2.125? 0.25, quarter of an inch, that looks pretty good. 0.45, not too bad. So now that I have that profile cut out, tasks. Oh, and it looks like we don't have to worry, we're actually fully constrained. So I'll just recompute real quick. Okay, so now I can close. And let's do tasks, pocket. And let's go 0.075 on that depth. That's not too shabby. So we have a nice little cutout, save some weight. I'm going to add that 5 on the end. It looks like that didn't come in. And then say OK. And OK. Alright, let's do a multi-transform. We go down to the pocket. Alright, first thing I'll add is a mirror transformation. And it already has selected the right plane, so I'm going to add a linear pattern. Alright, let's switch to vertical. And I can reverse direction. And we'll set this to a length of 10.5. Okay, we'll give this 4 occurrences. Okay, so with that detail added, I can again orient and save. Now I'd like to add my fillets, as I said before. So first thing I'll do is select, if it will let me. There we go, this edge, and fillet. So let's try 300 thou.
That's pretty goddamn legendary! I fucking avoided the amp and it still made the cycle!
In your photos, okay?
I would say the waterflow violence. What? The waterflow.
And that seems like a reasonable size. Okay, so at 300 thou, let's add a reference. There. Okay. Next, add another reference here. And let's add a reference here. And add another reference here. All right. Adding another reference. We'll choose that edge. Adding another reference on this edge. Okay, now this edge. Okay. So now I've got a much more organic looking smooth curvature. I can say OK. Now I can orient and save. Okay, now I would like to add a few more fillets. Let's go around our valve bosses here. Getting back into a fillet. Alright, so we'll do 200 thou as a dimension here. And we'll add this. And I'll add a ref and go here. And here. And add a ref here. And add a ref right there. And we'll add one here. And I'll add here. And here. And here. And we'll add a ref. And adding another. And there. Moving right along to here. And add another ref. Here. And last one here. And again, orient and save. I like to add some smaller fillets. In here. Alright, so we've got a fillet. We'll go with 70 thou. And I'm going to come over here, add ref, here. Alright, I'm going to accept that. And I'm going to orient, save. Alright, now I want to put some fillets in some of our newly created features. Some of these are going to be a little bit tricky for FreeCAD, so I'd love to fillet this area, but I don't think it's going to happen. So I'll move on to adding a fillet onto that edge. We'll give that a dimension of 75 thou. So we'll go with 70. I think the extra 5 thou kind of throws it off. So that's a really beautiful curve there. Let's add some refs. And we'll move down. Yep, so we'll get these other two. Add ref. And add ref. Add ref. Add ref. Add ref. It's a tricky one. Add ref. Okay. Okay. Orient. And save. Okay. Let's add some more fillets down here. So I've got a dimension of 60 thou here, and that's a pretty good fillet. FreeCAD did a good job managing that fillet too. So we'll come over here and add ref. Add ref. And finally, add ref. Okay. A few other things that I'd like to fillet. Let's go through the return, the oil return. Coming around here. So give that a dimension of 120 thou. And I'll add ref. Okay. Okay. We're looking better and better by the second, I think. Okay, so let's orient and save. All right, now I'd like to record myself doing some chamfers. So let's start with, I guess I have to select an edge like I would a fillet. And let's go with chamfer here. And let's go with something like 55 thou. And what you're seeing here, if you can see it, is my Dell dock has a really hard time with graphics. So it's not a malfunction of FreeCAD, this is actually a Dell issue. So there's 55, I'll add ref. There. We'll add some more refs. There. 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 And good opportunity to orient to get the view of the other ones. And we'll add another one here. Here. We'll go here again. This is a Dell issue if you're seeing it. I don't know if you can see it, but if you can see the flashing right now, that's a Dell thing. So it's not FreeCAD's fault that Dell docking sucks and has for months, if not years. Here. If I could do it again, I would reconsider buying a computer for personal use. That's a Dell. Or company use. I want to also put a chamfer on these. That looks really nice. Again, if you can see any nonsense up here, I apologize. That Dell docking sucks. Alright, so we've got those done. I'm going to say OK to accept it. And save. Well, this is not looking too bad. Let's view. Appearance. And we'll take this to be something like, oh, I did not mean to do that, but Chrome. And if Dell docking would settle down, look at that shine. That is absolutely fantastic. And then if we set a color to the environment, look at that nice shine. It almost looks like with the graphics you'd be ready to stick that right in an engine. Well, this is probably as far as I'm going to take this on the video. I think it's decently complete. I thank you for watching with me. I hope this has been a helpful adventure, and best of luck in all of your FreeCAD adventures. See you in the next video.